Yora, good evening. Welcome to Code
Hello.
Night New Zealand. And tonight we have a special guest, Mohammed. How are you?
Hi. Hello. I'm Muhammad Ahmed.
Yeah,
Yeah. Working
yeah.
on yeah, sorry. You go first.
Oh, I'm just gonna. Well, you can introduce yourself, but like Mohammed and I worked a long time ago in the same company, and it's been like a pleasure just getting back to sync with you because I felt like really excited when you come up like with the session ready, set, deploy .NET microservices in AWS. So what do you bring to us tonight?
Yeah. It's kind of like the summary of what I learned last year, I guess. AWS was new to me as well. So I prepared this um, kind of intro demo and prepared this repo. It's kind of teaching me and reminding me of what I learned last year. And I was like, yeah, why not sharing it with everyone? It will be nice.
Yeah, that's really cool. Yeah, I really support that sort of like those sessions, right? Where you're like bringing like a introduction or your experiences with the platform. And that's really cool. Excited like for the session tonight. But before we get to start, Mohammed, let me just introduce the user group for all the audience. And if you're coming like here for the first time, so we're Code Night New Zealand. We are a community group of developers. We love coding. We follow best practices on software development languages and technologies. Uh, in general, we tend to focus more like the Microsoft stack, but it's really interesting that tonight we're talking about like AWS, right? So you're really open to any stacks in here, right? So we're not locked onto the Microsoft stacks. And the intention of the user group is to enable developers with practical knowledge to excel and launch their careers. So you're always going to find really good contents from introduction level to more advanced level. So anyone coming here always takes like good learnings from the sessions we share. I'd like to mention that we are part of AzureTime.com. We're a cloud native group of enthusiasts where we get to share and talk about the latest and greatest in the cloud native space. We're sponsored by .NETFoundation.org, which is an entity that looks after the different open source .NET projects, and JetBrains, software tooling for developers. Right. With no further ado, Mohammed, I'm gonna bring your screen. Yeah, the floor is
Lovely.
yours, man.
Awesome. Thank you
Let
so
me
much,
bring
Marcel.
here. Nice one.
All right. All right. So this is like an intro to AWS and .NET. I'm gonna talk a lot, and please, if you have like any questions, shoot it to us. Interrupt me anytime. Um, yeah. So let's start. Today I'm gonna talk about some of the AWS components that we're gonna use today. Not all of them, just the ones that I handpicked for today. And then we'll try some of the microservices concepts. Today is not going to be about concepts at all, but there is one or two slides about concepts. The rest of it is just demo and show you stuff around the AWS console and the code and stuff like that. All right. Um, cool. So there is some of the AWS services that I'm going to talk about today. So let me start by from the left to right. The Lambdas, of course, they're serverless. They're fully managed by AWS. Um, they run for maximum 15 minutes, so you have to be careful what are you running into the Lambdas. Cannot run more than that, and it can run 1,000 concurrent execution at a time. Yeah, it can scale up very quickly, scale down very quickly. You don't manage scaling up and down; it does it automatically. You don't even need to specify anything. It's very fast as well. It can scale up to um, the whole 1,000 concurrent execution in 1 second. So if you got a burst, it's very flexible. It's an ideal choice if your functionality kind of works with the Lambda. Support many languages. It auto scale automatically, as I mentioned. Completely stateless, and you pay per request. Um, yeah, so we're gonna use the Lambda heavily today. The next one we're gonna use the SQS. Again, serverless. It has a standard or first in first out kind of queues, and the first in first out support also like uniqueness in the queues. In the standard, sometimes you get duplicated messages, so you have to be careful around that while you're doing your code. Um, it's a one-to-one communication, so you have a sender and a receiver in the queue. Um, the messages can stay up to 14 days maximum. So you have to work around your logic if your logic requires the message to stay longer than that. I don't know why, but you have to move it somewhere else. You can move it to DynamoDB or anything else you want. The message size cannot be more than that, 256 kilobyte. But there is a trick where you could put your message in S3 and then put the link of the message in the SKS, right? So you don't have to put the whole message in the SKS. We're not going to do that today. We're going to keep it simple. We're going to use just simple messages, but that's a trick if you're like an actual user of the SKS. Can trigger Lambda functions. You pay for per request. The SNS, it's a little bit different. It's one-to-many communication. So you can have one person putting a message in the SNS and multiple people listen to it. It will get duplicated across. Call it fan out. So it fan out across the queues. You could also attach email, SMS, mobile push notification into the SNS. So it has more functionality, right? It's a little bit different than the SKS. And the last one is the ECS. It's the last one on this screen. There is a couple more in the next screen. It's serverless, but it's not completely serverless like the Lambda. It takes a lot of effort away from you, so it's serverless. It's a containerized approach. I highly recommend Fargate as well, and it autoscale. But on the ECS, you have to specify your autoscaling rules. Do you want it based on the memory CPU? Do you want it based on the queue size? How do you want it to scale up, and how do you want it to scale down as well? You have to specify those rules. In the Lambda, it does it automatically for you. And then here you pay per the CPU and memory. Have a bit more for today. The API gateway, you can define your endpoints. You can connect it to Lambda or ECS. Stages, you can define stages like deployment environment, testing, production environment. And the most powerful features is the usage plans. You could throttle the users. You could have an API keys, and you could do canary deployment where you deploy it to 10% of the user and then 90% if it's good, and then 100%. So you could gradually roll out your changes. DynamoDB, serverless NoSQL database. It automatically scales up and down like the Lambda. You don't have to specify much. Single-digit millisecond latency. It's really, really fast database. You can stream, capture the table activity, which means if the data ever changed in the row or the document, you can get notified, can get triggered. We can trigger the Lambda using the DynamoDB, and we have an example of that today. And you can specify time to live. You could say, I'm going to put this data in the DynamoDB, and it lives only for 1 day. After 1 day, it will be automatically deleted. That's very convenient. And we're going to touch on the CloudWatch today as well. We're going to look at some metrics and logs, and not a lot of or dashboards today, but you still can configure those in CloudWatch. All right. So that's the bit of the concepts that we're going to talk about today. In the traditional world, in the monolith world, you would have multiple tables. And back in the days, we used to have one store procedure that has one transaction that updates the data in the first table. And if the update is correct, it will update it in the second table. And if all the business rules are correct, the transaction will commit and upload in both tables simultaneously. So it guarantees the data atomacy, and the data will always be consistent at any given time. That in the back in the days. Now we have microservices. It broke down those to multiple microservices. So each one is separate. Um, the order table is separate than the warehouse table. And when you have an update in one, it doesn't necessarily guarantee the update in the other. So you would have a queue and it will update the other one after the first one succeed, and so on and so forth. So with that mindset shift, you have to um, it follows the concept of eventually consistency. So the data is not consistent now, but eventually it's going to be consistent. It's a very important mind shift to have when you're dealing with the microservices, because yeah, the nature of the microservices, of course. When a transaction fails, there's a lot of things you could do. You could retry, you could undo that transaction, or you could have like a two-phase commit, which is my least favorite option in those two. The two-phase commit still keeps you in the old days kind of mindset where you still have a transaction, but that transaction now is distributed across multiple services, and all of them have to guarantee the consistency. And then you have a voting phase and you have a commit phase. It's very complex. It holds a lot of resources, and it's very hard to scale as well. So my two favorites is the retry, and if you retried, couldn't do much, you have a manual processing at the end, or you could completely undo the operation and reverse it back. So if someone paid money, you could refund the money. If yeah, whatever, you could undo that operation, right? So let's jump in. So today is all about the learning that we could have in AWS, and how we can build a microservice in AWS from scratch, right? How we can get to an advanced level very quickly. So today we'll start with very simple examples, and I will dive into a little bit more details in the simpler examples, like you can see the code, you can see the pipelines, how it's getting deployed, yada yada yada. Very very simple details, very minor details, and then we can graduate to more complex scenarios, and we're going to see more of SQS patterns and some of the SNS patterns as well at the end. Yeah, so let's start with the first one. It's a very simple ECS API. Okay? Today, I'm not going to focus about security. I'm not going to focus about scalability. I'm just going to focus about how this works, right? How we can
Yeah.
deploy the AWS. What's there? What's out there, right?
Yeah.
Um, so for that simple API to work, there is a lot that need to be done, right? We need to get the ECS. We need to have a Fargate inside it. We need to have a couple of services. We can create them. We can call this the first API. The orange one could be API 2 and 3 and so on. Inside each API, there is a task. The task is the actual container that runs the API. For each task, you have a definition. The definition is just like something that defines the description of that task. What is the URLs that you're going to use? What is the ports you're going to use? What is the descriptions of the task, right? And once you deploy that, you have a task ready. Although you need an ECR container registry, and the registry just holds your container image. And usually you have a lot of versions because you deploy a lot, and you have always the latest one, the last one you deployed. So the latest one will be taken and will be converted to a task, or you could instantiate a task from that. And based on the definition that you have, you will have a container running. And we'll see steps by steps today how we can do that. So let's open Visual Studio Code, and let's have a look at the simple .NET ECS API. That's the one we're talking about today. And we could see the source code is extremely simple, because today is not about writing code. It's about deploying it to AWS. So you have an extremely simple application here with one controller that returns a random numbers, random range, supposed to be a weather forecast, and it will return random range of date and temperature and summary. All right. There is nothing much to it, and that's your solution. That's your project. That's your source code. Now let's have a look at the cloud formation. Now the cloud formation, I didn't touch on it before, but it's the way that you deploy stuff to um, AWS. It's like the ARM templates in Azure if you're coming from that um, area. And we could see here the most important part is those ones. So let me search and find those. Here you have your parameters in the template, and you have your resources. So here I'm having a log group where I could log my logging. And here I have a role that allows it to allows the ECS to assume a task, and allows it to access the ECS tasks. And here you can access also the ECR, container registry, could download it, you could do some stuff to it as well, and you could have logs. This is not a secure way of doing it. You need to specify the resources. But again, today, not focusing on security much, we're focusing on how this works. So you have your task definition, the one that we talked about, and you're giving it a name. You're defining, oh, it's a Fargate. This is the CPU, this is the memory. I wanted to use this virtual private cloud, which is the default that AWS gives you. But again, the default is not secure, so you have to work around that, making it more secure and stuff like that. But we're going to deploy it to the default network that the AWS is giving us. And here you can see that's the role that we specified earlier. And ARN is the AWS resource name. And we're just getting the name of that and giving it to the ECS, to the task definition. We're using ARM because it's cheaper. We're using Linux as well because it's cheaper. And in the free tier in AWS, or I didn't mention that, you get like 720 hours per month for free. So you get a big number of hours for free per month, and you could deploy your stuff and test it, and it's all for free. And let's define our container. This is the image path. It will come from this account, from this region. It will have this name, and we'll always use the latest image. We're going to use this port for our API, and we're going to use these logs. Right? We define the tasks, and now let's define the service. This is the name of it. We're going to use this cluster. We're going to use Fargate. This is the task definition that we specified earlier. We only want one container for now. It's a simple API. If you wanted to start with multiple containers, more than one task inside the service, you can specify the number here. And this is the subnet. This is the security group. And it has a public IP, so we can access it as well. The security group, we're defining the protocol, the port numbers, and the CIDR that is going to be used for the tasks. It's a bit of stuff that we need to set up for a simple API, right? But
Yeah.
Fargate guarantees the scalability of your application, so you can scale out and in very easily. And it also it's kind of in the middle between having a simple one container running and having an AKS running. It's somewhere in the middle where it gives you a lot of flexibility. It's very powerful, while it's not as complex as having a Kubernetes. Yeah, so you have that task definition, you have your service, and that's it. And I've seen Fargate being used in very high scale production applications, and it's very good. I highly recommend it. AWS as well highly recommended it. All right, so we have our infrastructure here. Having a look at the pipeline, we're not doing much. We're building .NET. We're debugging some stuff just for sake of it. If you have something not running, you can have a look at it. We're getting the ECR. I could have hard coded this bit, but it's really nice example to see how you could use the AWS shell script. And this shell script is just getting a URL, really. Doesn't do much more than that. And this is the first step of, sorry, I didn't specify. This is the first step of building. After you build, you're going to deploy, and deployment will be downloading the artifact from the build. And this is just a debug as well. And we're doing a Docker build and Docker run, building our containers. And we are pushing the image to the ECR. Remember, in our presentation, we have this bit here. It will push the image to the ECR, and then it will deploy our CloudFormation, which is our infrastructure. So it will deploy the service, the tasks, and it will create your container. Let's have a look at the pipeline. Oh yeah, before we have a look at the pipeline, let's have a look at the README file. In each example of those, there is a README file that explains how you could test it, how you could run the pipeline in the pipeline, but how you could test it in AWS. So we can open the console. We're gonna go to the figure out the URL, go to the Swagger and test our API. Before testing our API, let's have a look at the pipeline. Sorry for the inception there. Which one is it? It's a simple ECS API. And here is the build step, here is the deploy step, and yeah, push it and deploy the stack. Let's have a look at it in AWS. Here in CloudFormation, you could see the stack. So you could see the simple ECS API. You could see the resources that we created, the service, task definition, and some security group, log group, and the role itself. Let's go to the service. Right. So here is our service. Here is all the tasks. We specify just one task inside that service. And let's go to the networking. And let's take the public IP and copy it. Add it here. And then add the next, just a port number and then Swagger. Right. This will open our API that's being hosted here in these tasks. And we can try it out in execute. And here's our now random data that we specified in the code. And that's your first API. Right. So we're going to use this template and this way of working across the other ones as well. But particularly, I mentioned Node.js Lambda here because it's quite simple. And you're going to see the difference, especially in the CloudFormation bit. You can see the node Lambda here, simple node Lambda. And you can see the code, what it does. It's calculating the area, and you just multiply two numbers together. That's pretty much it. Have some logs so we can know what the data is, and that's it. As usual, we have the template here, how we can test it. And let's have a look at the CloudFormation template. You have a very simple Lambda here, and you have a role. You're allowing it, and that's it. You're allowing it to use the logs, and you're allowing it to assume a role. And that's it, really. The pipelines are quite simple as well, where you prepare the zip folder and you deploy your infrastructure, and then you deploy the code on top of the infrastructure. 3 simple steps. So all the complexity that's from the .NET is from the ECS and the Fargate and the build of the .NET and deploying that on top. If you don't have all of that, it's quite simple.
Mm.
Let's see the pipeline. It's not going to be much different, nothing special in the pipeline to be fair, but let's have a look at the Lambda. Simple. Which one was it? I think it's this one, my Lambda function. If you're not sure, we can have a look at the name here. This is the folder name. This is the Lambda. You can have a look at the cloud stack. Yep, it's called my Lambda function. And this is the one. And in the code section, in the .NET Lambda, you cannot see the .NET code here. But because this is Node.js Lambda, you could see the code. You could update it here as well, and you could retest it. Of course, this is not going to update your repo, but at least it's something you could play around with. And let's try to test our Lambda. Let's take this JSON here, and let's put it here, and let's test it. Oh, it gave us something. I like green. Yep, you can see the area is 42. This Lambda works fine. And it's quite simple. All right, we saw the .NET Lambda, we saw the Node.js Lambda. Let's see how we can use those two together. Let's see how we can use an S3 bucket, and whenever someone uploads something to the bucket, it will automatically trigger our .NET Lambda. That's another example. Let me close that. Other ones. And we call this simple.NET Lambda. I guess I could be better at naming stuff, but sorry, I'm not too good at naming things.
No, all good.
Yeah, so it's quite simple here. You could see the diagram, and this is the diagram referenced in the documentation. So you could come and update it here, and you could see our source code. It's quite simple as well. And you could see the cloud formation, and let's see it on AWS. Let's see it on the portal. How does it look like? You can see simple.NET Lambda. And here in the triggers, you could tell from here that it's being triggered by an S3, and it tells you which S3 that triggers this Lambda. So the way to test it is not like the normal way here. We have to trigger it by putting some file in that S3. So let's go to that S3, and let's try to upload something. First of all, let's see how we can test it. We can go to the AWS. Sorry, yeah, we can upload something, and then we can go to the console, go to the monitoring, and see the logs, and we should see a message in the logs. Yeah. So let's upload something to AWS S3. Sorry, I'm gonna upload this file that I prepared before, and I'm gonna hit upload. Now there is a file here called upload me to S3, and let's see if the Lambda saw this file and got triggered and executed the logs. So let's go back to the Lambda. Let's go to monitor. Let's go to CloudWatch logs. And it's not easy to open the logs from here because this is like grouped in a way. So it's easier to search all log streams and then search for your message in all log streams. And you could see here that it picked up the file. You could see the event details. This is the event that S3 pushed to the Lambda. And you can see our file here. A lot of
Can
other
you zoom in a little bit more, like on the browser, Mohammed?
Yeah, absolutely.
Yeah, cool. Yeah, that's good. Thank you.
Yeah, so you can see our file here. Alrighty. So we executed this example. Let's move to the other example, a bit more and different things. So what if you want an API that is extremely reliable? Um, this is can provide an excellent availability and excellent because most of it is serverless functions. The more serverless functions you have, the less you have to manage, and the more reliable it becomes. So when you have an API gateway that's calling a Lambda that does something on the background and return the result, it's going to be extremely reliable. One of the AWS simple architecture that they highly recommend people to use for their website, especially if it's a static website, is to have a Lambda and to have an S3, and you put your website in the S3, and the Lambda is just replying to that. You could have a cloud front in the front as well to have like some kind of a CDN approach going on, and that website will be extremely flexible, extremely scalable. Could do the cloud front in multiple regions. So yeah, the simpler it is, the better performer it becomes. So let's see how we can do that in AWS. This is a simple. This is a Lambda API, right? That's this guy here, and you can see I don't have much. Where is the API? Where is the Dynamo? I can only see the Lambda here, the code of the Lambda. Everything is in this template file. And here you could see our API gateway. And you could see the resource in the API gateway. It's just, yeah, a bit of configuration for the API gateway. My path is going to be hello for my API. You could have any other path. You could have a method. My method is get. And the get function is integrated, and it's calling this Lambda here. And here is the Lambda resource name. And you have a deployment. This is like if you have a multiple environments, you could have, this is my stage. I call it prod. You could call it anything. And then you give a permission, and you invoke the Lambda. A permission for the Lambda to be invoked by the API gateway. And you have your simple Node.js Lambda. And you have a role. You can assume a role. And this is just a copy paste stuff. Really, it shouldn't need to have an SES, but you do need a DynamoDB here. And this is your DynamoDB table. And it's called hello track as well. So you're basically giving the Lambda permission to access this table here, right? Quite simple. And I have my Lambda, and if we had a look at it, whenever it get a request, it creates an item, and it will put this hard-coded message, and it will call DynamoDB client, and it will put a record in the table. Quite simple. And it will return a status code of 200, and it will return the item that it's saved in the database. Every time it will be with a different ID. And that's it.
We got a question, Mohammed.
Yeah.
So, it's related like to the logging, right? So, like the question is there, like, so since Lambda is serverless, would there be a problem for debugging and tracing log statements or application files, etc.?
I don't see the point between it's serverless and there is logs, because each instance of the Lambda will put the logs. So you have the logs from all the
Correct.
instances, and you can
Yeah.
easily search all the streams. So you don't have a problem there.
So with the logs, so in the cloud, well, So the way how you are tracking there, like on the Lambda, so you have those consoles or the message. So if you have like any way of tracing that, you would be able to monitor or what's happening.
Right. You need something like a correlation ID or something like that to make it consistent. Yeah, so you could search for stuff quicker and find stuff quicker. Yeah. Um, although that doesn't come by default, so you have to implement it in a way.
Yeah,
Usually people have a header, and you can pass that header around, or you could do any automatic instrumentation if you want. But yeah,
yeah.
it's
So
something
I think I
something
think
that
I think the question, like yeah, as you said, like nothing particular with serverless, but how you instrument your application to capture logs, right?
yes, it's pretty much. There is nothing out of the box for it, unfortunately. So it has to be on the developer to implement that. Um, all right. I'm happy for the questions. So please share as much as you can. It feels
Yeah,
lonely without the questions. All right. So we had a look at the template. We saw the DynamoDB, we saw the Lambda, we saw the API gateway. Uh, the pipelines is quite simple as well. Um, you have you deploy the Lambda, you deploy the CloudFormation, and that's pretty much it. There's no much to it. Let's have a look at it in AWS. How does it look like? Instead of going to Lambdas, I'll go to API gateway. Yeah, we have one API gateway, and we have one resource in that API gateway. Here you could have your stages. So if you have like um, development, testing, and production. Um, yeah, so let's go back to the resources. Let's go to the get function that we created. You can see here that it integrates to a Lambda function, and you could see our Lambda here, the Lambda API. So this is kind of showing you, oh, the client will call and we will integrate this API gateway to the Lambda and back. So whatever response the Lambda is going to give, the API gateway is going to give it back to the client. And here, last one, you could see test. We could test our API gateway from here. Let me review the README file very quickly. So you could see our diagram here as well. And you could see resources. You could choose Git, you could test it, and just hit the test button. You don't need to put anything in. And this is the hard-coded message. So once we hit the test, we're going to go and look into this message in the DynamoDB table. Let me open DynamoDB as well. I'm pretty sure I tested it before the presentation. So let me see if there is any records here. So you could go to explore items, and you could go do a scan. You could see this old record that I tested with. Let's delete that. Yep. So there is no records now. And if we triggered it, we're going to have a new record here. So let's trigger the API. Yeah. You can see a long log. Let's see if we can find our message. Yeah, we can find our message from the Lambda. And let's have a look at the table again. And here we go. We have a new record. Yeah, same time as now, 8:40. Lovely. We could also have a look at the Lambda. We could see the logs in the Lambda as well. I'll try to be a little bit faster as well because we're running out of time. All right. A bit of a different architecture here. And this is just to see how different things could work together. Like you could have an ECS that publish things to the queue. You could have a .NET that listen to that. You could have a Node.js Lambda that publish messages as well. So this is kind of an example to show you how you could set up something like that. And it's quite simple in the code as well. So it takes you, this is called queue reader. And here you have the different components in the diagram. You have the publisher, you have the queue reader, and you have a common class, yeah, very simple class that everyone is referencing it and using it. And in the README file, it also showed you how we can test it. So same way as we did earlier, you put this in the Lambda, and then this should go into the queue, and the reader should be able to read that and execute it on function. All right. I'm eager to get to this point so we could explain a little bit. It looks complex, but it's quite simple. This is the pattern that we have here, SQS pattern. And what it says is this Lambda is going to publish some messages, and then in this queue, and then this message processor is going to read it from the queue, right? But what if it failed in a real world application? It's not going to be always lovey-dovey and pinky. It's going to have some failure. So what if something failed? It's going to go to something called the dead letter queue, and
Mm-hmm.
the processor already have some kind of retries mechanism going on already. So it will retry it a couple of times between the queue and the processor already. But those kind of retries is very quick retries. It has like almost milliseconds in between or no time at all. So it's very quick retries. Sometimes you need a cooldown period where the API is hammered and you need some time for it to cool down a little bit so you could retry again and it works, or you have a network problem. If you retry it quickly, it might not work, right? So it end up in the dead letter queue and it stays there for maximum for 14 days, remember that. Now, the Lambda, this Lambda here, it's going to pick it up from the dead letter queue, and I configured it to pick it up after a couple of minutes, not right away, or we can configure it to be that. I did it very quickly for the presentation to be very quick and pick it up quickly. But normally in real life scenario, you want it to cool down a little bit for, I don't know, a minute or two, 5 minutes, picks up from the queue and it puts it back again in the queue. This Lambda here will have a couple of retries as well. So you don't end up in an infinite loop where you have a bad data coming into the system that's looping inside your system forever, right? You want it to exit the system somehow. And here at the end, we have a failed queue. So this is the last resting place for your bad data. And if it ended up here, you need to have an alert and you need to do some manual intervention because that means something bad entered your system and they were not able to process it. The system wasn't able to process that. So you might need to tweak some code. You might need to fix some stuff and put it in the queue again, right?
It's a typical integration case, right? Where you're, well, in there, like you work with like the messages, but in most of the case, you're trying to retrieve that and deliver somewhere else. In case that one fails, right? So you could have like this sort of dead letter queue that you would have like this sort of process to pick that up and retry, right? And do like this sort of
Yeah,
reprocessing. Now that's very, very popular pattern.
yeah.
Yeah.
And it's very powerful as well because you have an automatic retry here, and you could potentially have like something like poly with another kind of retries inside your
Yeah.
API or service, whatever this is. So you kind of have first level of retry, second level of retry, and finally a third very laid back level of retries. So let's see how we could do that. I don't know if we have time, Marcel.
We do. Yeah. Just carry on. Generally, like we have like some sort of window of until we get to run all of the code. It's all good.
Lovely. All right. Um, so we can see here the architecture diagram again. See some a bit more detail because this is a little bit more complex than the earlier examples. And here's the payload that we have. And I designed it in a way that if you put bad, sorry, if you put bad in front of the message, it will treat it as an exception message and it will throw an exception in the background. I could show you the bit of the code that does that very quickly. So you have here your message processor and you have your program, and it's just a simple one program file. And here you have the handler. And inside the handler, if the message starts with bad, just throw tantrum. It's a fake and exception, and it will help you debug things faster. Right? So we have two scenarios here. One happy scenario with a simple uh, message and a bad message. And this is the interesting one, because if you have a bad message in the system, you want it to end up in the failed queue. So that's how you tested it. You put it in the system, you wait for a couple of minutes, and then you look at the failed queue, and you should see your message there. We do have some maximum retries, and you could play around with those numbers. So if we see the CloudFormation here, I'm sorry, it's easier to just take this. Take this and search. Yeah. So you can see in the template here, there is a variable called maximum retries. And this is inside the function that actually retries it. If we goes to the queue again, this is the function. And if you, the function code is quite interesting as well. Because this is a pattern, you're going to use it over and over again. The function is quite simple to write it with Node.js, doesn't have much complexity. And it's a generic function as well, so you could use it across domains. And what it does is it looks at the body of the message, it sends the message to a queue, and if you finish, sorry, where's the bit of the code that I'm looking at to maximize the retry? Oh, sorry, this is the wrong Lambda. This is the one that I'm looking at. Yes. So you're just taking a message from a queue and passing it to another queue. And here it looks at the attribute retry count. Every time you retry it, you're going to increase that count by 1. And if you hit the maximum, you're just going to go to the failed message queue, right? So if you hit the maximum, you're just going to put it in a different queue. So this Lambda is very generic, so you could use it across multiple domains, across multiple APIs, and you could have this exact same code running across all of them. And the max retry here by default is 3, but you could configure it as much as you want, right? And this is our Lambda here. Yeah, that's it really.
All right.
Yeah. I have one last one, which is the SNS pattern, which is quite simple. The one that we talked about before. Lambda publish it in the SNS. Instead of publishing it in the queue directly, it will publish it in the SNS. And this will replicate the message across the queues that you have. So let's say you have an example of an order. Someone orders something from your online website. You want to fulfill that order, and at the same time, you want to update the warehouse database to say, oh, we decrease it from the um, entries that you have. So you could potentially create 2 queues and 2 workers here. Each worker will do something, and it will happen in parallel. It's very reliable. If anything failed, you have the pattern here as well for the dead letter queue and the failed queue. You always carry on this pattern. You're carrying it along with you for every queue, because every queue will need dead letter queue processing. And the last one, I'm sorry I'm rushing things a little bit here, but the last one is It's very interesting one. It's called circuit breaker. And the circuit breaker is, if you have a slow responses, sometimes are worse than failures. This guy here have a YouTube channel. It's called Electro Boom, and he tried to create a heated seat, and he sit on it, and the cable was burning, and it it burned him in the process. So if he had the circuit breaker, he wouldn't be in that situation. That's all what I'm trying to say. Um, the circuit breaker is borrowed from the electricians, and every house has one of these. Um, and the idea of it is, if you have a high current or if you have a bad circuit, it will flip off, and it will save you from all the hassle that comes with with a bad system, right? It could break your refrigerator or whatever appliances you have at home. Similar to that, we have a system here, or a pattern that will break at this point when there is an API that is not responding. So let's say this API becomes slow, and sometimes it returns interim failures, and it's quite unreliable. A circuit breaker here will guarantee that when you have, you could also configure it the way you want, and you could say, hey, look, if this API gave me 2 bad responses in a 5-minute window, break the circuit. Everything that comes in after that is going to be outright failures without even passing it to the API. Why we does that? Why we do that? Well, first of all, we don't want to hammer this API with a lot of requests that it breaks it even worse. Second of all, we have resources here in the middle system that we want to keep. Maybe this worker doing multiple things at a time. You want to save the resources. It's using a lot of memory, creating a lot of utilizing a lot of resources, holding a lot of threads and a lot of transactions. Maybe you want to release those, and it will ease the system here. And since you're relying on a queue anyway, you would have a mechanism to retry. Whether that mechanism is immediate or after a couple of minutes, you would have a mechanism to retry after a while. A circuit breaker will definitely help you in those scenarios where it will break after 2 minutes or 3 minutes. However you configure it, it will come back to life, and it will retry again, and hopefully next time everything is running smoothly. So when you have a big systems, circuit breakers definitely help, but you always have to keep in mind that it comes with the price of complexity, and yeah, you have to deal with it after the fact as well, and things like that. Yeah, that's quite literally all what I have today, Marcel. And this is
Yeah,
the repo. Yeah, everyone can scan it. We'll go directly to that URL, and yeah,
yeah.
hopefully it can help someone one day.
Well, I'm gonna have like a check like on the resource. I I'm not seeing like any questions yet. Let's see if people like just push in there. So if I got like few questions, maybe like
Absolutely.
they are maybe like you know the answer, right? But like for example, the secret breaker. In general, like on .NET, we have the Poly as a library that helps
Yes.
us to do all of that. I don't know if there is anything specific to be configured on AWS that
No.
would remove that sort of dependency
No.
on libraries like
Unfortunately.
that.
Yeah. Unfortunately, you still have to rely on Poly. I think
Yeah.
it's the best option for now. They don't have any
Yeah.
automatic ones,
Oh,
as
good.
far as I know. I'm happy to be corrected.
Yeah. Yeah. For example, with cloud formation, right? In general, what I've seen other companies doing is just using Terraform to do the even like provision on AWS. I'm not sure. It seems like cloud formation is pretty like straightforward
Yeah.
to use. It reminds me like Bicep or even ARM
Yeah. True.
on Azure. I don't know. Like, so from your perspective, have you used Terraform with AWS? or mainly
Unfortunately, yeah,
CloudFormation?
I haven't used Terraform before. I only used CloudFormation and ARM templates, so I can only comment
Yeah.
on those two. But as you mentioned, it's quite straightforward, and I cannot see why people would use Terraform unless something I don't know. Um, but if I went again here, you could the way I break it down is a bit funny, and it's not the right way. But the right way will be each stack here will be your entire application stack. So you see how in SQS pattern, for example, we have multiple couple of lambdas and we have a .NET worker. All of those should be in one
Mhm.
stack. Um, and each stack here will be deployed and it will create the resources for you and good to go.
Yeah, so they are kind of grouped together, right? Logically
Yes,
together.
correct. Yeah.
Uh, we got like a question here from JK. So what's the benefit of using Lambda in ACS?
Oh, good question. So if you have like a long running application, something that is stateful, that requires a long running standing process that cache stuff maybe, or you use ECS for that, use a container for that. But if you have something stateless that just execute a function that has the time limit of maximum 15 minutes, you cannot exceed that limit. Otherwise, the Lambda is just going to break and try again. Uh, you could use Lambda. Um, so those are the two sides of things. Um, I cannot think of any other reasons right now, but this is the main ones: long running processes versus a quick uh, API calls or worker that does something and come back quickly or something like that.
Mhm.
Stateless.
Yeah. Is there a way like to extend the duration of lambdas, like
Um,
through maybe pricing tiers, or
no, unfortunately not. You cannot. 15 minutes is the maximum.
is it max? All right.
Yeah.
Yeah. Oh, my other question I have. Let's see if we have like more questions. So at the beginning you mentioned about the transactions with microservices. I don't know if you incurred in any scenarios where you need to rely on transactions with like a kind of choreography or any sort of orchestrations to manage that through messaging with microservices.
Right.
Just curious, like I'm not sure if you'll handle that sort of level of complexity.
Yeah. I haven't thought about that as well, uh, Marcel. But what I could say is the SQS, AWS provide the SDK for the .NET and for other like Node.js and stuff like that. That
Mm,
SDK is quite reliable. You don't do much. You just use the SDK as a um, it's a very high level kind of SDK. You just put your message and voila. That SDK will guarantee the connection between the SQS and your application. It will also guarantee if you have like a long running processes like that, the connection will always stay open. And I've seen it in real life production application, and it's very reliable. And all the problems that we have is always around our business logic. It's never around something broke in the network because SQS was down or something like that. Um, so you could rely on it for at least to glue your SQS with your Lambda or with your worker, and you could rely on that to um, um, flow the data from the beginning of it all the way to the destination. You could also rely on the dead letter queues and the retry mechanisms and stuff like that. But as soon as it end up in the failed queue, you have to have an alarm here because the consistency of the data is in jeopardy because you're relying on those for the transaction, and
mm,
those if that flow didn't work correctly, that means the transaction failed in a way. So you remember in the beginning we said eventually consistent. eventually consistent, because if one of those transactions failed and you need to retry it manually or do something manually to undo it or redo it, um, it has a hole in your data consistency, right?
Yeah,
I think that's the price we pay for microservices as opposed to the old school monolith way. But that's a
yeah,
simple price for the scalability and the other stuff we get for free.
yeah. That's true. Yeah. Microservices. Yeah, you need to think about like those scenarios, right? And rolling back or failing forwards. So there, it's yeah. I don't know if
True.
people nowadays are starting with microservices, but yeah, there are like additional considerations. We got like another question. Let's bring that in. It's about like the CloudWatch. So it's CloudWatch mainly for application log files and activity log files. Would you give a little bit overview about the CloudWatch if we still
Oh,
have the
lovely.
time? We still have the time, yes, for sure.
Lovely. I don't think I can say much other than,
Mhm.
yeah, you could have alarms in CloudWatch. You could say, oh yeah, if I get some messages in the failed queue, trigger that alarm and let me know. Um, you could have your own dashboards as well, and you could search and analyze the logs, and you have metrics as well. The metrics are the ones that I think I didn't touch on metrics, but let's have a look at them. So in every service, you have something like this, where you have your metrics, and you can see here the duration, the invocation. This is the one that we triggered just minutes ago.
Mhm.
Um, yeah, um, most of the people, well, you could use it definitely out of the box like that. But if you have like an New Relic or Datadog or any of those applications, you could also integrate it and then rely on them. But I think it has all of the main features that you would need, of at least the basic ones: the logs, the search, the alerts, and yeah, I think I don't have much to say about it, to be honest.
Yeah, I think people just need to try and validate. But it feels like with those alerts and having a way of raising those triggers, at least like basic functionality that with any sort of monitoring you would expect
Yeah, right.
would be there, right? So yeah,
Yeah,
just like those fancy dashboards. If you want something better, then yeah, perhaps you rely on other vendors. But yeah, it has the basic
true.
functionality, as you said. Yeah, nice. Well, a lot of questions. Thanks for participating. Yeah, that's pretty cool. And yeah, so far, well, I think that's it. I'd like to thank you, Mohammed, for coming sharing. It's always great seeing like a different perspectives, right? And I say that because I'm mainly like on Microsoft, on Azure, and exploring AWS is always like cool. There's always like
Yeah,
something new to learn.
yeah,
And
something
thanks
different.
for well being like volunteering, really. Like so,
Yeah,
Mohammed's one of like it's part of the user group. So he's been here like attending sessions for a long time. When we worked together, like previous company, we always chatted about it, and I invited him to come and share. And finally, you came, right? So,
yes.
yeah, so it comes here like to the audience as an invitation. So if you have like some content you want to share, that's a great opportunity. And Mohammed, you brought like in here like a introductory level, some sort of more advanced concepts as well. Really love it. Yeah, thanks for
Thanks,
coming
Marcel.
sharing. Yeah.
Lovely words. Thank you so much. I
Yeah,
appreciate it.
and do you have like any ways of people contacting you or get in touch if they have like future any further
Yeah.
questions?
I have my LinkedIn. LinkedIn is open for everyone to message me. Um, that's the best way. Yeah. Have my website as well. You could check out my website, and it has all my contacts as well. Um, yeah.
Oh, nice one. I've just put like your name here in evidence so they can see your website, so they have a way of connecting with you.
Lovely.
And thanks again. Yeah, I think like with that we are finishing. And yeah, thanks again, Mohammed. Thanks to the audience. Be in touch because we always have like sessions or monthly sessions, depending on how busy things are. Sometimes we have 3 weeks, every 3 weeks, most of the time every month. And yeah, thanks so much for staying with us up to now, and hopefully we get you catch up soon next month.
Awesome.
So
Yeah, lovely. Thank you so much, Marcel. Thanks,
thanks
everyone.
so much. Yeah,
Bye.
cheers.
Cheers.
Catch you guys later. Bye.